Hello friends, this is Mike from Wright, and this is the video explanation for SAT 2's Math No Calculator section, question number 9. This is a graphing linear equations question, or you could think of it as a systems of linear equation question. It kind of has elements from both. I'm going to show you two ways of doing the problem, basically in two different languages. One is going to be in the language of graphs. The other is going to be in the language of algebra. Graph way is going to be better. But first, let's just read the question. I'm going to read it off my paper. The question says, the graph of a line in the xy plane has slope 2 and contains the point 1, 8. Now, I've just translated this up here. Say this: the graph of one line, line A, the slope is going to be 2, and it's going to have the point 1, 8 in it. That's how I've translated that. It goes on. The graph of a second line passes through points 1, 2 and 2, 1. So they're describing a second line that's going to go through 2 points. And that's what I've said here. So there's line B, there's line A, and there's line B, two different lines. Line B has the point 1, 2 and the point 2, 1. All right. If the two lines intersect at the point A, B, what is the value of A plus B? So here, that's what I've said here. These two lines are going to intersect at A, B. And we're wondering what A plus B is. All right, so there's a couple tricky things going on here. First, I just want to say, just because they tell you, these two new, what seem like variables, these two new points, really they're just saying, take the point, figure out where they intersect, figure out the point where they intersect, add these two things together, and then tell us that number. They're not introducing two real variables. This is a common trick they pull. They're just having these sort of placeholder constants that really what they're just saying here is figure out where the two lines intersect, add the two numbers together, and tell us that number instead of just telling us the coordinate, for example. All right, so as I said, I'm going to show you two different ways of doing this. I mean, at its core, they're giving us really limited information about two different lines, and they're trying to get us to figure out where they cross. The two different ways of doing this, then, involve two different languages. They've presented the problem to us in the language of English, which is really by far the worst language to be thinking about this problem in. And so in solving it, we can either translate the English language description they've given us into the language of coordinate geometry, or the language of graphs, or we can translate the information they've given us into the language of algebra and solve the question using algebra. Now, a pretty common trick on the SAT is they'll present to you questions that are really difficult to solve in one language, designed to be intentionally difficult to solve in one language, and are relatively simple to solve in another language. Now, this question is pretty difficult, as you can see. I mean, I wouldn't call it difficult. Well, actually, I would call it difficult. Difficult to solve using algebra. It's long. It involves a whole bunch of steps. And it's a pretty simple question to solve in the language of graphs. Here, this graphing question is basically just we're going to make a graph of each of the lines, and then we're going to look on the graph to see where the two lines intersect, and then we're just going to name that point and then tell the test makers what point we've found. I'm going to take you through both ways of doing it, though, and I'm going to start with plan A. I'm going to start with what I'm going to recommend as the real way. And here I just want to say how you can convince yourself, like on the day of the test, like how can you know you're going to go for the easy way over the hard way? How are you supposed to know? I think in this question, because in the English, that what they're doing is describing a graph to you. Here they're saying, in the prompt they say, the graph of a line in the xy plane has the slope of 2 and goes through this point. They're literally, this question would be way easier, right, if they just gave you a graph. But they're not doing that because they're trying to make it intentionally difficult. And here they're telling you the story of once there was a graph, That kind of language where they're describing a graph is a big hint that this kind of question is best thought about in terms of graph, in terms of the language of graphs. That's a big hint that you ought to do this question by graphing it. If they're asking you to imagine a graph that looks like this, frickin' don't imagine it. Don't try to use your brain only to imagine it. Draw it on a piece of actual paper, and it's going to really help. The way of doing it in algebra is possible. It's a legit way of doing it. It just takes longer, and there's more chances for errors. All right, so the language should prompt you to do plan A over plan B. The language where they're describing a graph should prompt you to do the graphing solution over the algebraic solution. But let's look at how each of these solutions work. So starting with the graphing solution. Well, we have this information. Line A the slope, we have two lines. We're just going to try and graph each of these on the same plot. So line A, slope is 2, and the point it goes through is 1, 8. So let's just start with that point, right? So here's, I've just drew on a graph, right? Here's the x-axis, here's the y-axis, and we're going to look at the point 1, 8. Well, that's 1 over and then 8 up. So like 1 over and then 1, 2, 3, 4, 5, 6, 7, 8 up. So that's this point right here. This is where I'm starting, right? You have the point 1, 8. This is the piece of information we have about line A. The other piece of information we have about line A, in addition to it starting at point 1, 8, is that it has a slope of 2. What that means in the language of graphs is that, well, I mean, kind of roughly what it means in the language of graphs is like kind of steep and goes up like this, you know? Another way, sort of specifically, in terms of plotting it on the graph, another thing that it means is this is the kind of graph that whenever it goes to the right 1, it goes up 2. It goes up 2, right 1, up 2, right 1, up 2, right 1. That's the kind of graph it is. That's what it means to say that the slope of a graph is 2. Here on this, right, this is the kind of line that whenever you want to move it to the one to the right, it's going to go up 2. So that's what's happening here, right? If you want to extend this line on the graph, because the slope is 2, you need to move up 2 and then over to the right 1, up 2 and over to the right 1. Or kind of more importantly, you can move down 2 and then left 1, right? It's going to go slope of 2 same way. You can go up 2, right 1, or down 2, left 1. Either way, it's just going to look like this. That's what having a slope of 2 means. So for the rest of this is just me going up 2 and then, down 2 and then left 1. So here we started at 1, 8. We're going to go down 2. So here's 1, 2, right? 1, 2, and then we're going to go to the left 1. So there's this point. What is this point? It's 0, 1, 2, 3, 4, 5, 6. This is the point 0, 6. Right? And then we're going to go down 2 more and over to the left. So this is 4. So this is negative 1, 4. And then I'm going to go down 2 more and over to the left, right? So this is a negative 2, negative 2. And the line just sort of keeps going that way. That's what having a slope of 2 does. And you can just plot it going infinitely in either direction. Right? So I've just plotted it a fair amount in this direction, a fair amount in that direction, because we're not sure where it's going to cross yet with the other line. So to begin, right, we don't have this line, and we only have this line plotted, and now it's our job to figure out what the second line looks like, and then to see, like, just to look and see where they cross. So the information that we're given about the second line, line B, is 2 points. We don't have any information about the slope. We just have 2 points. So let's just plot those 2 points. Here, the first point is 1, 2, so that's 1 over and then up 2. So that's this point right here. So here's the point 1, 2. And the second point we're given is point 2, 1. So that's 2 over and 1 up. So we've got basically what they're giving us is these 2 points. Well, so ignoring the rest of this, right, we're just going to connect these 2 points in a line. These 2 points are the points we know. And then we can basically just extend the line in both directions. Well, because we know it's down here, we want to just extend the line in that direction because that's the direction it's going to run into the other line in. And the question is, like, you know, how do we know what direction to draw the line? Like, how do we know how steep the slope is? And the answer comes from these 2 points. You know, it's going to go, you know, over to the left 1 and then up 1 in order to get from here to here, right? The difference between 2, 1 and 1, 2 is like a left 1, up 1 type move. Doop, doop, right? And this is what I said here. This line is a down 1, right 1 kind of line. This is down 1, right 1, down 1, right 1, down 1, right 1, right? The difference between these 2 points is that it's 1 over on the x-axis and 1 down on the y-axis, or 1 over on the x-axis and 1 up on the y-axis, depending on what direction you're going. So we're just going to extend it in that direction. We can't go here and then have it jump way up here because it needs to be a line. It needs to be straight. So we're going to take it from here, go left 1, up 1, and then we're just going to keep doing that. Left 1, up 1. So here, this is 1, 2. We're going to go left 1, so it takes us to 0. And then we're going to go up 1. So this is 0, 3, it looks like. So we're going to doop, doop. And then we're just going to do that one more time again. And this is negative 1, 4. And then we're going to do this again. This is negative 2, 5, etc. And this is enough because we've gotten to the point where these 2 lines are crossing. Right? So just long story short, we've graphed both of these lines using the basic information that they've given us. Here, the slope of 2 and the 0.18, that's enough to draw a graph of a line. They've told us start at this point, draw a line from there with the slope of 2. Right? Same thing here. They've given us 2 points. Take these 2 points, draw a line through them, and then just keep that line going. Right? That's essentially what we've done. And so we can just look now at this point and ask, where is that point on the graph? And the answer to that is, well, it's over 1 on the x-axis, so it's at -1. And how far up on the y-axis is it? Well, it's 1, 2, 3, 4 up on the y-axis. So our point that we care about is 1, comma 4. That's the point. That's the answer. Right? Well, here they're asking us, in the actual question, they're asking us, what is a plus b? Right? None of the answer choices are in the form of a coordinate. They're asking us just numbers, and the number that we care about is a plus b, where a comma b is the point where they're intersecting. So here at this point, 1 comma -4, what that means is that a plus b equals -1 and 4, -1 plus 4. Well, -1 plus 4 is 3, so a plus b equals 3. That's how you can arrive at the right answer using graphs. Okay, I really actually still want to push that you should do it in this way. But that said, if you're under timed pressure and you're having trouble drawing the graph, your hand's shaky, or you're not really sure like what point is which, and it's hard to tell because you don't have that much space, algebra is always a solid fallback. And actually, I always recommend to students, whenever they get stuck trying to solve a question in one language, to switch to another language and see if you can't give it a try in a completely different language, see if that doesn't unlock anything. So let's move now to plan B, the algebra plan. Here it's going to look, well, you're going to see some similarities. You're going to see same themes, some of the same information sort of cropping up, but in a completely different way. But we're going to start with the same information. Here we're going to think about each line, and we're going to try to figure out the equation of both of those lines based on the information we have, based on the slope and the point for line A, and based on these 2 points for line B. And then using that information, we're going to figure out algebraically where the point is that these 2 lines intersect. And really, that was kind of a graphic explanation. Really what we're going to do is solve the system of linear equations. Right? We're going to have one y equals mx plus b and another y equals mx plus b. We're just going to use algebra to solve that, figure out when the y's and the x's are both the same. All right, so let's get started. First step is we're going to start with line A. We're going to figure out what the equation for line A is, right? I want a y equals mx plus b form of an equation for line A. So the information we have about line A first is that its slope is 2. That's what they said. And it goes through the point 1, comma 8. All right, well, we want an equation in the form of y equals mx plus b. And here the slope is 2. So m in the mx plus b, y equals mx plus b, that's going to be 2. So we know part of our equation already, right? If y equals mx plus b, y equals 2x plus b, because they've told us that the slope is 2. So this is what we're saying. We're substituting 2 for m, y equals 2x plus b. All right. Now, the other part of the equation that we need in order to have a nice y equals mx plus b equation is b. We have y equals 2x plus something, but we don't know what that something is. We do, however, know one of the points that it passes through. We know an example of an xy coordinate where the equation holds true. So what we can do is plug that xy coordinate in for x and y and solve for b that way. So that's what's going on right here. We're substituting in this point, 1, comma 8, for the x and the y in this step. So instead of y equals 2x plus b, now we've got 8, because 8 was the y coordinate, equals 2 times 1, because 1 was the x coordinate, plus b. Right? Now we've got an equation that's just all numbers and b. We're going to be able to solve for b. All right, so 8 equals 2 times 1 plus b. That's just 8 is 2 plus b. Then you can simplify that by subtracting 2 from both sides. So then we got 8 minus 2. 8 minus 2 is 6 equals b. So b is 6. And I tried to be really clear that the 6's are different than the b's. I'm doing my best here, guys. 6's are curly up top. All right, so b equals 6, and that completes our equation. We know what the slope is. We know what the y-intercept is, right? We know what m is. We know what b is. And so that's enough. We have a complete equation for line A, y equals 2x plus 6. All right, we've gotten here, we get b equals 6. We've got y equals 2x plus 6. This is the algebraic equation for line A. Now, actually, I just want to peek back and say y equals 2x plus 6. This looks familiar. Look at the y-intercept up on this graph. Here's 1, 2, 3, 4, 5, 6. Here's the y-intercept of 6, and the slope is 2. It looks like the graph that we just drew. So that's nice. OK, so we have the equation of line A. And we're wondering, where does it cross line B? So the next step is to figure out, like, what is line B? Like, who even is a line B? So we're going to jump up over here and use the information that we've been given from line B to figure out the equation. Again, the y equals mx plus b form equation for line B. All right, so line B, we've gotten 2 points, 1, 2, and 2, 1. And we want to get into the form y equals mx plus b. Now, this is a little bit more complicated, but when you have 2 points like this, the fastest, easiest way to get from there to a y equals mx plus b type equation is to solve for m first, using the slope formula, or rather like using your knowledge that slope, what slope is rise over run. What slope is how much upness happens for every time a certain amount of overness happens. It's the change in y divided by the change in x. Algebraically, the way of putting this is that m equals y2 minus y1. You're going to pick 2 points and say, what's the difference between their y's? And then you're going to divide that by x2 minus x1. You're going to take the difference between their y's and divide it by the difference between their x's. That's going to be the slope. Now, this is convenient algebraically because we do have 2 points. We have 2 y's. We have a y2 and a y1. And we have 2 x's. We have an x2 and an x1. So that's what's going to happen in this next step here, where all of these y's and x's change into numbers. That's where I've substituted in the points 2, 1, and 1, 2 in for these expressions. Here it looks like y2 is going to be this one, y1 is going to be this one. So we've got 1 minus 2 here. And then x2 is this, x1 is this. So we end up just by substituting these 2 points in for this little formula. We get the slope, m, equals 1 minus 2 divided by 2 minus 1. All right, so we can simplify from there. This is just addition, right? And 1 minus 2 is negative 1, and 2 minus 1 is 1. So this simplifies to m equals negative 1 divided by 1, and that's just the same thing as negative 1. Negative 1 over 1 is negative 1. So this is our first sort of major milestone in solving for the equation of B, or of line B, right? Is we figured out what the slope is. The slope is negative 1. Now that's what's reflected right here. Here I've just taken this y equals mx plus b form, and I've substituted in the fact that our slope is negative 1. And we got y equals negative x plus b. Here's negative 1 x plus b. Now we're in the same situation as we were over here, right? We have the slope, but we don't know the y-intercept. That's what we're at here, right? Y equals negative 1x plus b, and we need to know what the b is. And again, just like with line A, we have a point. So we're going to plug in the point for x and y. Knowing the slope, we're going to be able to solve for b, because we're going to have a bunch of numbers and a b. We're going to get b alone, solve for b, and then we're going to have our complete equation. All right, so I'm going to sub in the point 1, 2. You could use either of the points. It'll work either way. But here, let's just plug in the point 1, 2. And so here, the 2 is the y. So instead of y equals negative x plus b, we've got 2 equals negative 1, because this is 1, negative 1 plus b. 2 equals negative 1 plus b. That's the result of our substitution. And then we're just going to simplify from there. We're going to add 1 to both sides to get b alone. We're going to take this 1, move it over here. So now 2 plus 1 is 3, so 3 equals b. And then we're going to take this b, now that we know that 3 is b, or that b is 3. We're going to take that y equals mx plus b equation. We're going to put 3 there instead of b. Right? And that's what's happening here. We're substituting in b equals 3. All right, so y equals negative x, because we figured out the slope was negative 1, plus 3, because we figured out the y-intercept was 3. So here we've reached our second major milestone, right? We have the equation for line B. Line B is y equals negative x plus 3. Incidentally, just like with the other one, let's look over on the graph. Right? Negative x, or let's start, so positive 3, the y-intercept needs to be plus 3. Well, we saw that. Here's 1, 2, 3. This is where it crosses the y axis. And then the slope is negative 1. It goes right 1, down 1, right 1, down 1. And that's what's happening on this graph right here. It's just got a slope of negative 1. So, not a coincidence, obviously, that these two graphs look the same, or that we can arrive at this at the actual equations using 2 different methods. But anyway, good to know, right? Okay, so now we're in a situation where we have the equation of one line and we have the equation of another line. From here, this could just be a systems of linear equations question, right? We had to do a ton of work to get to the point where we're like, now we have to do a freaking system of linear equations question. But at this point, it's like, okay, we have one equation that says y equals 2x plus 6. We have another equation that says y equals negative x plus 3. And they're asking us where these two intersect, right? If the solution to the system of linear equations is the point a comma b, right? Find that point, add the two things together. That's going to be our answer. And this is a relatively easy system of linear equations question. This is easier than most of the actual systems of linear equations questions that they ask on the SAT. Right? And it's easier because they've given it to us both in y equals mx plus b form, or well, we've given it to ourselves in y equals mx plus b form. So it's easy to substitute. You can use the substitution method to say that because y is 2x plus 6 here, and y is negative x plus 3 here, that these two things must be the same. So here, this 2x plus 6 comes down. Right? So here's y equals 2x plus 6. This 2x plus 6 is from here. And this negative x plus 3 is going to come from this equation. And here, this is just us saying these two equations, we're going to force the y's to be the same, and we're going to set them equal to each other. So 2x plus 6 equals negative x plus 3. This is the substitution method of solving a system of linear equations. Okay, at this point, we just need to solve for x. So this is just more algebraic manipulation. Here, 2x plus 6 equals negative x plus 3. Let's get this x over on to the other side. So we're going to add x to both sides. This gets rid of this x, right? Negative x plus x, that's just 0. 2x plus x, that's going to be 3x plus 6 equals 3, because this 3 is still here. And now we need to get rid of this 6, so we're going to subtract both sides by 6. So we've got 3x equals 3 minus 6, that's going to be negative 3. And then we're going to divide both sides by 3 to get rid of this 3. And we've got x equals negative 1, because negative 3 divided by 3 is negative 1. All right, so our x coordinate of the solution, right? The first part of our solution of where they cross is negative 1, right? And again, it matches. Okay, now that we have the x coordinate, we can just take that x and plug it into either one of these equations. You could plug it in here, you could plug it in here. You take that x, plug it into either one of those equations, and then you can solve for y. This is like how to solve systems of linear equations question. This is why I said, this is kind of a systems of linear equations question. So we've solved for x. X is negative 1, and I'm just going to bring it over here and substitute it in for this equation. So here, instead of y equals negative x plus 3, we're going to have y equals negative 1, because x is negative 1, plus 3. So y equals negative 1 plus 3. Well, that's the same as y equals 1 plus 3, because negative 1 is just 1. So 1 plus 3, y equals 1 plus 3. Well, 1 plus 3 is 4. All right, so the x-coordinate of the solution is negative 1. The y-coordinate of the solution is 4. So the point, god damn it, is negative 1 comma 4. That's it right here. A comma b, this point where they intersect, that's negative 1 comma 4. Right? Well, none of our answers, again, are in the form of coordinates. We're not done yet. We need to take these two things, add them together, and then tell them the answer that you get when you add them together. So we're going to do that. Right? If a comma b is negative 1 comma 4, then a plus b is going to be negative 1 plus 4. And that's the same as 4 minus 1. And again, so a plus b, that's going to be 3. Negative 1 plus 4 is 3. Okay, two different ways of solving that question. And here I really just want to emphasize, again, this was so long and hard. Think about all the places where you could have made a silly mistake and gotten totally, thrown off track. This was relatively easy, You got to be careful, I guess, about how you draw your graph. But you have a fair amount of space, on this page. You can do it in the space for the question below, I think. You got a lot of space, generally speaking, enough to draw a nice, big graph. Be careful with how you mark your lines. And so long as you do that and you draw a nice, pretty graph for yourself, you can figure this out, And you could get, look how much less I had to write on this one. So again, I think the hardest part of this question is realizing that you should use the graph, right? That graphing is the way to go. And again, the key to figuring out that you should go with plan A over plan B is reading the prompt. The prompt is given to you in English. The prompt is presented to you in English. But it takes the form of like describing a graph to you. They're like, imagine a graph. Once there was a graph in the world. It was the most beautiful graph of them all, right? That you should take that as a key, a hint that what you should do is draw the graph that they're describing. Because oftentimes when they do that, it's much easier to solve in one language than it is to solve in the other. All right, that's it for this question. I'll see you all in the next one.